The graph of y equals 1 over the negative 2x squared minus 0.5 was reflected in the x-axis, and its image is shown. So here, this is sort of different than all the questions that we've had so far. Normally, we were given the picture and asked to draw the image. Now they're telling us the original equation and drawing us the image after it happened. So you got to be really careful with the wording of these questions. Sometimes it's just one word that can change the meaning of the question. What is the equation of this image graph? So this graph here that I put in a blue box was reflected in the x-axis, and the red graph is what we got. So can you see that the blue one would have had to have been, that would have been in the original graph. And that's the equation of that original graph is in the blue box. We want to find the equation of the red graph. So, again, I find especially with more complicated equations, and once you start adding more things than just translations and reflections, that the function notation is the most helpful. So what does the function notation look like here? Well, if we're reflecting in the x-axis, which way and what coordinate is being changed? It's the y-coordinate that's getting multiplied by the negative. And if the y-coordinate is getting multiplied by the negative, that means the negative is outside of the function. So the equation for our red graph, oops, keep it red. The negative is outside of the original graph. And if you wrote it like this, full marks, because you're showing that that negative's outside, and that is a correct equation. Now, mathematically, if you would check in the back of the book, they're going to simplify this. So what do we do with that negative outside? And this is another place that I find that we could have a common mistake. So I'm gonna give you 3 scenarios. I want you to think about whether scenario 1 is right, scenario 2 is right, scenario 3 is right, or whether all 3 scenarios are wrong. Would I do that to you? Maybe. Or whether 2 of the scenarios are right and 1 is wrong. Scenario 1. Okay, I'll write them down so that we can see all of them here. Scenario 1, I'm going to multiply the top by the negative. Scenario 2 in black, I'm going to multiply the top and the bottom by a negative. Scenario 3, I'm going to multiply the bottom by the negative. And when I multiply the bottom by the negative, you'll notice in both scenario 2 and scenario 3, I distributed it. Okay? So I'll recap. Scenario 1 in green. What did I do with that negative out in front? I multiplied the top by a negative. Scenario 2. What did I do with that negative out in front? I multiplied the top and I multiplied the bottom by the negative. Scenario 3. What do I do with the negative out there? I multiplied the bottom by a negative. So, are they all wrong? Are they all right? 1 wrong, 2 right, 2 wrong, 1 right. Start over here with Ramsey. You think the middle one's right? Okay. Devin, what do you think?
I was going to say the middle one, but my next choice is probably the third one.
Okay. So in between the middle and the third?
I think the first and last one is right.
You think the first and the last one are right? Good. We've got 3 different answers so far. First and the middle one are right. All right. So obviously not everybody can be right. There are some right and some wrong. So they're not all 3 right. What went wrong and how can we explain it? Well, we have to go back to a little bit about multiplying fractions. Okay? In the first one, I'm going to just give myself some space here. In the first one, I multiplied only the top by a negative. So that's like putting a fraction out front, multiplying the top by a negative 1 and the bottom by a 1. That's what I did. What is negative 1 over 1? Is it a negative? Yes. So that is correct, because that's the same as before. Now, if I multiplied in part 2, I multiplied the top by a negative 1 and the bottom by a negative 1. What does that make this out in front? That makes it a positive 1. And if I multiplied the top by a negative 1 and the bottom by a negative 1, I've actually changed this to a positive, so this one would be wrong. In the third one, what did I do? I multiplied the top by a positive 1 and the bottom by a negative 1. Is that equal to a negative out in front? So this one is also correct. Now, is there a preference? They're fine. You could leave it either way. I mean, when I see the final answers, I feel like I like the blue one the best because it has more positive values in it. But you would be able to write it either originally how we did it. If you left it like this, they would accept that. They would know that you understand the right place where the negative is. If you wrote it as the blue, they would accept that because you've distributed the negative correctly. And if you wrote it as the green, they would accept that because you've distributed it correctly as well.
Simplify the green one even further by just timing the top and bottom by both -1.
You could, and that would be it would get you to the blue one. Because so what Peter's saying there is if I multiplied the top and bottom by -1, you're really multiplying by 1, and I've found in the past that that's usually your best times table. Most people know their 1 times table pretty high, like 1 times 7, got it right away. And you can like even go in bigger numbers. It's like your best times table. You know, you go to your other numbers and then things get a little tricky, right? 19 times table, not so good? No, see? Up to 12. Most people are like, you know, you learn up to 10, and then somewhere at the end of maybe grade 6 to grade 8, they start saying, oh, you should know up to 12. And then they sort of say, yeah, that's good enough. So, well, I know tricks to do things quite high quite quickly. I'm a little rusty, but for a while there, I really had my 20 times table like really good, like 17 times 16, 272, just would know it, but I'm a little rusty on some of the ones, like the 19s, a little bit here and there. Questions for this one? 7, 8, 9, and 12.